Okay, so this is going to be our second video on resolving forces, or well, resolving vectors actually, key ones in forces. So because of that, I'm going to use a different vector apart from force. And but most of the questions I prepared will be on forces nevertheless, which is a vector. So let's look on what we want to start on. So let's say I have a ball and I throw it in the air, and it made a 30 degrees to the horizontal, and it's traveling in this direction at 5 meters per second. This ball, or any other vector, will need to move two ways. It will move moving upwards, and it will also move in sideways. Now, upwards motion will be called, or you might see we'll use terms like horizontal. We might talk about x, and it might be horizontal component. That's a word that we'll use, or might call it x component. This one we might talk about our y component based on the diagram that's beside us as well, and this might be called our vertical. All right, so for short, I'm gonna call it y component, and for short I'm gonna call it x component. Alright, so we're going to resolve this vector into its two components. Its y component and its x component. Let me erase this to get some space. Alright, for the space now, we're going to use simple triggers. We're going to form, so this was 5 meters per second. We're going to form a right angle triangle here. And what's going to happen here is that this is going to be my y component. So that we form that parallelogram again, and this will be the opposite side of my triangle. This will be my hypotenuse, and this side will be my adjacent. I'm going to teach you a trick, skipping out the trick portion, but I just want to get it under your belt, just in case you're mathematically inclined and can manage that. So we can say sine theta is equal to opposite over hypotenuse. We can say cos theta is equal to so toa, that's hard to remember, adjacent over hypotenuse, and tan theta is equal to opposite over hypotenuse. And those are gonna be what we'll be using in order to figure out how do we arrive at the x component and y component. So let's start at the x component. X component. Looking here, your x component is your adjacent side, and we know the hypotenuse. Therefore, adjacent and hypotenuse is cos. So we'll end up with cos theta is equal to the adjacent side, which is going to be your x component, over your hypotenuse. So in order to get the x component, we're going to end up with an equation of your hypotenuse cos theta. Or in this scenario, since we're talking about velocity, we're going to end up with v cos theta. And that's what we would end up with. We can write this equation down. The x component is actually equal to v cos theta. And this only applies when the angle is to your horizontal. Later on, we might look at changing the angle, and then I think the last question will change the angle, and we'll see how that might affect if we get sine or cos. But if you want to use this equation always for your x component, just ensure that you're taking the angle from the horizontal and you will be safe. Let's look on your y component. Your y component would be your opposite, and if you remember, we would have sine theta is equal to opposite over your hypotenuse Here, let's say sine is equal to opposite theta is equal to opposite, which is going to be our y component over our hypotenuse. And give me a second, let me erase this. Let me put that at the top here. So y component is equal to here hypotenuse sine theta, or let's call that v sine theta. And we're going to use these two in order to resolve our vectors into x and y component. So after this, we're going to move into a question in resolving some forces into x and y component. Alright, so let's look on this question. It says find the magnitude and direction of the resultant force. So here we have two forces. One is called A, it's 5 newtons. One is called B, 10 newtons. The A is 60 degrees to the horizontal, B is 45 degrees. Let me remind you of your planes. So let's look at the Cartesian plane. Here x is positive, here x is negative, y is positive, and y is negative here. We're going to follow the same rules. So here we notice that this is going this way, so we have positive x and positive y. Notice that this is going this way though, so we're going to have negative x, and it's still going up, we're going to have positive y. So we're going to keep that in mind when answering this. Alright, normally I like to create a table to answer this. I'm going to just quickly create a table for you, and we're going to have vectors. I'm going to have x component, and I'm also going to have y component. I have a vector A and I have a vector B. I'm just going to quickly jump into it, and I'm going to call x component. So we're saying let's look on your x component, y component. As we said earlier, our angle is to the horizontal, so we can just quickly put down cos, so we know that it will be cos, and we know that it will be sine for these two. Alright, so we're looking at A. So A, the vector size there is 5, this is 60, this is 5, and that's also 60. Plug that in your calculator, you'll end up with a value of 2.5. So it's going to be 2.5 newtons, and this will be 4.33 newtons. Alright, now we're looking at B. Notice that B is moved from left to right, therefore this should be minus 10, and the angle there is 45, and we end up with minus 7.07, and here y is positive, it's going upward, we're going to end up with 10 sine 45, and we'll end up with 7.07. I'm going to have these forces, I'm going to call this Rx, resultant for the forces in the x direction, and we're going to end up, when we add 2.5 minus 7.07, we're going to end up with minus 4.57 newtons. My point is not showing, and Ry, we're going to end up with 11.4 newtons. Alright, now what happened here is that we're going to have two forces. I'm going to have a force going this way, and this is going to be, it's not writing, I'm going to input Rx, and it's going to be equal to 4.57, and then I have another force, we're at right angles going downward, and Ry is going to be 11.4. So if you remember in our first video, when we have two forces acting at right angle, we're gonna need to use Pythagoras theorem, and we can find that force there. And in order to find the direction, we're gonna find this angle to the horizontal. Notice that I didn't put back the negative there. Negative just means that we're heading in that direction. Give me a second, let me erase this from here. Take that down. You can pause the video and take that down if needs be. Okay, so we know that our resultant force is gonna be equal to Rx squared plus Ry squared, and both those should be square rooted. If we put negative here, some of you guys might be uncomfortable not putting the negative there. If you square negative and you square positive, you're getting the same answer, and all of this should be square rooted. We'll end up with 12.3 newtons. Alright, how do we get the direction? We're gonna use tan. Tan theta, so I want this angle right here is equal to opposite over adjacent. If I go ahead here and complete my parallelogram, this is gonna be my opposite, that's gonna be my adjacent, so I'm gonna end up with theta is equal to tan inverse of 11.4 over 4.37, and therefore I'm going to end up with an angle of, can't see my answer, I think it's 60, let me calculate this, that's my answer. Let's grab my calculator and calculate that. So it's going to be tan inverse 11.3 divided by 4. Cool. And I end up with an angle of 69 degrees. I'm gonna stop this video right here, and I'm gonna upload it as part 2, because I think the other part of the video is gonna be a little bit longer. So I'm gonna stop, and it's gonna be part 2. There'll be a part 3 and maybe a part 4 depending on the time.